So, hello and welcome to the FluCoMa podcast. So today I'm going to be talking to two people, Zakiya Leeming, who is a composer who specialized in working with scientists and health data researchers to create music informed by their work, and Dr. Christopher Melen, who is currently the research software engineer at PRiSM, which is Royal Northern College of Music's Centre for Practice and Research in Science and Music. So Zakiya is currently a doctoral researcher at PRiSM, and the two have recently collaborated together on Zakiya's piece, Sad Dog Eating, which was informed by machine learning processes and was part of the unsupervised concert series. Today, we're going to be exploring the piece and learning about the relationship between composer and engineer. We should also be hearing about their experiences with the FluCoMa tools. Chris, who has already begun using them in some of his own work, and Zakiya, who has recently taken a look at the tools and is interested in incorporating them into her practice. So, Zakiya and Christopher, hello, and thank you for being here today.
Hi, Jacob.
Hello. Thank you for having us.
You're quite welcome. So on the podcast, I generally like to start by learning about people's practice and how they got into what they do in order to give a bit of perspective for the rest of the discussion. So this is the first time I've had two people on at the same time. So I think I'll try and avoid just asking you each the same question and having you each answer in turn. However, perhaps to begin, Zakiya, you could start by telling us what it is that you do and how you got into it. And then Chris, perhaps you could do the same.
So I have always been drawn to science and technology in my compositional practice, and that's taken many forms. And it has led me to working with PRiSM over the years. I was a part of the very first 8 Cubed series, which paired scientists with composers, and I was working with a neuroscientist. And this was the first time I was able to really collaborate with someone else in a way that wasn't a performer or someone else in the artistic medium. And so it was really a turning point in the way that I worked, the way that I approached ideas in my music, and the way that I felt the ideas from science and technology really had a more central aspect in what I did.
And so, Chris, perhaps you could tell us.
Yeah, well, you're right. That's my job title, research software engineer. I think I got that around the right way this time. I often and get it wrong. But yeah, research software engineer, which is quite an unusual role to have at a music conservatoire. I might in fact be, I think I'm the only one in the country, and may very well be the only one in the world. Perhaps one of the listeners will correct me on that. Email and correct me. Yeah, I actually worked at Huddersfield before this job. I was on the project, Cage Concert Project at Huddersfield, starting in 2015, and that was a project which essentially turned one of John Cage's pieces into a web app. We had other outputs as well, including a book and a CD. So after that, I came to work at RNC and PRiSM. In my earlier days, I actually worked in industry, so I hadn't come straight, into academia from university or anything like that. So I had quite an extensive industry background outside of academia. I'm a composer as well, but my background is in music, not computer science. So I'm kind of a self-taught programmer. We're doing mostly machine learning at PRiSM. That's the majority of what I do. We have a small data center here, and I feel very privileged and lucky, basically, because I get to do my hobby for money, which is not something that very many people can say. I wouldn't be any good at doing anything else anyway, let's put it that way.
Yeah, so you both talked about PRiSM, which is, I'd like to hear about PRiSM as a centre, because it's obviously the institution that's brought both of you together. So Zakiya, you're a part of a number of doctoral students at the centre. And so, Chris, you've been the research software engineer since 2019, I believe. So I'd love to learn about what happens at the centre from the perspective of the enabling software engineer, but also from that of a composer. So I don't know who would like to jump in first there.
Well, maybe I'll start because I've been with PRiSM since the beginning, and it really grew out of the work that Emily Howard, who was my supervisor at the time, was doing in her own work. She is similarly drawn to ideas of science and how they can inform a compositional practice. And Emily developed this centre that was really looking to do what some of what I discussed earlier in bringing composers and scientists together, because it's one thing, I think, to, as an artist, have an interest in science and to want to explore that in my work, but it's to be able to actually speak with an expert in that field, be able to ask the questions and really get to grips with the parts that maybe weren't so obvious or easy to find out about. That was really important in, I think, finding this space where you can actually start to bridge these gaps of language. And that's really what this centre is about, is finding new ways to communicate. It's finding new interdisciplinary knowledge and expertise. And also, as we've seen with PRiSM SampleRNN, developing new creative technologies.
Yeah. And so, Chris, how would you describe what happens at PRiSM from your perspective of?
Yeah, well, you're correct. I've been working with PRiSM as research software engineer at PRiSM since 2019. But as Zakiya intimated, that because the history of PRiSM goes back a little bit further than that. So it's not just it's been around in its current form. We have a lab space there in RNCM. Neither of us are actually there today. But well, I mean, one of the things that kind of hit us actually was the pandemic, as it did with everybody, and so we spent a lot of time away from the lab space we have there. But it's pretty amazing. We have a small data center there, which again is rather unusual for a music conservatoire. That's not the kind of thing that usually exists in that kind of context. But it's so it's a working space for staff, PRiSM staff, students, research students, and we're also a multi-institution center. We have staff working around the country. It's not just at RNCM PRiSM, so we're multidisciplinary, multi-institution, and my role as a research software engineer. I'm writing code, obviously, but the code is in the service of, being used for actual work now. It's not simply code that's written and just published and then it's just sitting there. It's stuff that's being used by PRiSM and collaborators with PRiSM, and it's not just a kind of static thing. So it's a very dynamic environment, and it's pretty amazing to be working there.
Yeah. So the code that you're writing isn't just kind of going up on a repo somewhere and not being used. It's actively.
We really from the get-go we were keen that wasn't to be the case, because that is the case a lot of the time, particularly with machine learning. A lot of code, machine learning code, is published with a paper, and it then doesn't get touched. There's a lot of bit rot in the machine learning world. It just happens, it's the way it is. We were really keen that wasn't going to happen, and so we set up our GitHub really early, and we published the first code. I think the first code really published was PRiSM SampleRNN in mid 2020, so mid pandemic, if you like. But we were working full steam ahead on that at that time, so it wasn't kind of affecting us too much at all, really. And yeah, we have quite a few libraries available now, and we have a few more to be published very soon, actually. So, and we have a small community based around GitHub, our GitHub site, and yeah, it's nice to have that, for the code to be used, not just sitting there. And yeah, it's a nice little community, and I maintain it. I'm the main kind of person who maintains the code. So yeah, it's great.
Yeah. So yeah, as you say, one of the major machine learning outputs and softwares PRiSM is this implementation of SampleRNN. Yeah. So I wonder, Chris, if you could perhaps, in more or less layman's terms, kind of explain what this software is doing, broadly how it works.
Yeah, so I guess one way to describe it would be neural synthesis, which perhaps needs a bit of unpacking itself. So it's essentially using neural networks, AI, to generate audio. Now, exactly how that audio is then used is, kind of not the job of the software to decide, but it tends to be used as a compositional tool. And most of the people that I've worked with are composers, sound artists. So it's a form of unsupervised machine learning. So it basically takes a data set of audio, which would be supplied by the composer generally, and that's used then to. So the software is then learning the patterns in the data set and generalizing from that. So the idea is not simply to learn the data set literally, which it can actually do, but generally you don't want that. You want it to produce something that's new, but has some kind of relation to the data set. So I'm talking about, we're using this with living composers, but recently I did I ran SampleRNN on the entire Beethoven piano sonatas. And of course, he's not living anymore. And he's not around really to give me any advice on what he'd like the software to do. But so the piano sonatas are the data set, so they're pre-processed, and then the software is run on the data set. The end result then is something that is not identical to Beethoven. It has aspects of the Beethoven sonatas in it, but it's generalizing from that. So, and I should also point out actually that SampleRNN is not PRiSM's own invention. There was a paper published in 2017. So it's an implementation of an algorithm that already existed, the SampleRNN algorithm, or machine learning architecture, I should say. It's not strictly speaking an algorithm, which was published in 2017. But I mean, it's the case. We tried to get that software. There was software published with that paper as well, but we tried to get it to work, but we couldn't. It had basically fallen into disrepair. So we decided to implement our own version. And so it has some extra features, and it's optimized, and of course it's maintained. There's also, your listeners might have heard of the DataBots on YouTube. So if you go onto YouTube and type DataBots and Relentless Doppelganger. So this is a YouTube stream that is using the previous version of SampleRNN, the original version of SampleRNN, to generate a continuous cycle of technical death metal, of all things. So if you go onto YouTube and search for that, you'll find that. It's quite an interesting listen.
Yeah, I'll link to that down below to where this is, as I will do with everything that we'll be discussing. Yeah, well, you were talking about yes, obviously the algorithm existed beforehand, but it's also about bringing those kind of algorithms to artists and composers like Zakiya and things like that. It's much like with FluCoMa, our neural network is an MLP regressor, which obviously wasn't invented by our team, but it's a question of bringing it into an interface that's going to allow artists to use it in powerful ways. Great. So I think it would be really interesting now to sort of hear how practically that kind of technology has been used in a creative context. So the piece that we're kind of articulating things around today, Sad Dog Eating, so incorporated some of this technology during composition. So just to preface, so the piece was part of the unsupervised concert series, which is, I think has now had 2 editions, is that correct? Yeah, and this was the first edition, I believe. So perhaps before we talk about that relationship between you in collaborating to bring this piece alive, perhaps Zakiya, you could give us an overview of the piece, tell us about what is happening in it and what you were wanting to achieve.
Yes, so when I came to compose this piece, I had been working on a cycle of compositions that all revolved around the central idea of an iterative process. And there had been workshops that I had been conducting with 3 clarinetists during that time, and this was right at the beginning of the pandemic and through the early stages, where we were having to work over Zoom. And I remember there being, at that point in time, a very large discussion around how to manage this new instrument, or some people might liken it to a performer or some collaborator or whatever their approach to that framing was, which was this new piece of technology that we were passing our musical thoughts through, which was Zoom or other online platforms. And I remember thinking very early on that it was a strange idea to me to want to recreate the idea of a concert space within this particular setup, because that's clearly not what it was going to do. That's not what its latent purpose or properties were. And so I was more interested in finding out if this is the new space within which we perform together and we listen to each other and we construct ideas and develop them, and then receive concerts or participate in online events. What are the capabilities of it? What does it offer? What does it add? And so I worked with the clarinetists to construct this idea of the apparatus, which was the performance space and the rehearsal and workshop space. And this included the Zoom technology as an intermediary space through which all of our communications were passed, as I say. But it also included the recording devices that the performers had to hand. So we were looking conceptually. The project initially was to investigate the particular properties of clarinet multiphonics, and specifically with respect to performer and instrument pairings. So what was possible and what the sonic properties of each multiphonic were, and in consideration of who that person was, which performer it was, what instrument they were using, what sound environment, what room they were in, and how all of those things came together to result in the experienced sound. As multiphonics in particular can be very changeable. They can be they're very sensitive to influence from a lot of these different factors. So that was the primary purpose originally of our investigations together. But with this new idea of the environment now shifting and having morphed into this apparatus as I conceive of it, we were looking at how that could be captured and how we could investigate these things, which seemed at odds with each other. It seemed initially, it seemed the idea of investigating the physical sonic properties of with performer and instrument pairings in a physical environment, and suddenly we were not in a physical environment together. And so what we came up with was the idea that we would I asked the performers to record on their mobile phones, which was the devices that they had to hand. And I liked the idea, actually, that these were although that these days phones are very good at recording compared to devices not even that long ago, these are still not, they're not devices that are specifically designed for the capture of musical performances. So I liked that idea. And we, in leaning into this even more, what I asked the performers to do was to unmute the Zoom so that when they were playing together, we had two instrumentalists who shared a property. They lived together. And so two of the clarinets shared a physical space, and the third clarinetist did not. So we had each perspective coming through Zoom, and the performer who was overseas, who was performing through Zoom, his performances were coming through the Zoom on the other end of the two performers who lived together here in the UK. And on each end, and including mine, any sound that was made was coming through the Zoom and then also being recorded on the devices as they were playing. So this gave a number of different audio perspectives that each had a different level and type of transmediation of the sound. There was a transformation on each end within each moment that was performed in that performance in which they are technically playing together. That was actually, if you listen to that same moment coming from a different audio perspective, there was a different level and type of mediation of sound that was coming out through their Zoom from the person on the other end. So there was a high degree of technological mediation already in what I then curated into this data set that I took forward into the next composition. So the piece that I had created as a result of that initial workshop process, Output 6, that was focusing on the idea of dislocality and the idea that some of the performers would sometimes, when they were playing the multiphonics, they would say afterwards that they couldn't tell who was the cause of certain parts of the sound, even including the person who was in another country over Zoom. So that was the purpose of that piece, really, to investigate that. And then when I took that data set onto this process, I was interested in this idea of the next iteration of this material, the next, what would it become under different circumstances, but also with this idea that the technology and the technology is a part of the process and as a mediator of our experience. I wanted to then take it to the next step and say, well, what if we add machine learning to this process? What if we take the workshops and all of these ideas of dislocality, of mediation of sound, of not being able to tell sometimes whether the resultant sound sounded slightly technological in a way, it had that quality to it, whether it was because of actually the physical act of playing a multiphonic, which can sometimes already have a mediated sound quality, or was it the Zoom platform, or was it a further process of my own sound design, which I also then did. So when I took this forward to this piece, I was thinking about this data set in all of those different ways, and that was where I got up to when I then met with Chris in order to start this training process.
We'll of course get onto that right straight away, but I just had a quick question about the use of multiphonics, because it's something that lots of composers that have been using these kinds of technologies, often this idea of multiphonics often comes up. For example, Alex Harker's piece with oboist Neve Dell for FluCoMa was an exploration of multiphonics, and these ideas of fragility and the physicalities of having to produce multiphonics and stuff. And I'm really interested to know what motivated you to explore that kind of sound world, if it was this sound quality that was quite ambiguous between technology and an acoustic instrument, or what were the motivations behind exploring the clarinet multiphonics?
Initially, I would say, first of all, this is something that I had wanted to explore, really dedicate a good and proper exploration to for a very long time. I think, particularly as a composer, it can be difficult to really understand how to use a technique, especially when it is so malleable and it's so changeable, and it's so different when you bring different performers into the equation. And so when I was invited to join the Garden of Forking Paths project, which was run by Scott McLaughlin at the University of Leeds, and he on the topic of clarinet multiphonics, I jumped at the chance, because, as I say, this is something that I really wanted to just really delve very deeply into for some time. And my initial, I think, just as a person, just generally, I think my initial first desire in these circumstances is sometimes to want to catalog and to record and to produce sort of a list of things that maybe I can use as a reference in the future to look back on. But what I knew actually was going to probably serve me far better, given what I knew at that time about the nature of clarinet multiphonics, is actually to take a more performer-driven, environment-driven, approach to actually stepping back and providing a set of materials and tools to look at clarinet multiphonics, or to invite them in or to investigate them, but not in a way that I'm trying to sort of pin butterflies onto the wall. So this is really where the idea of the project, to think about the collaboration between not just the composer and the performer, but the performer and the instrument, the environment, really exploded out into this way of working together that was much more. It was much more of a step-by-step journey that would ask at each point, what did that do? Why did it do it? Or more specifically, wasn't that interesting? Or what happens if we do this? So, for instance, when I brought one of my graphic scores to the process, it was because one of the performers had mentioned how when they had thought about something slightly differently, a thought had popped into their mind whilst they were playing a multiphonic, it had changed the quality of the multiphonic. And so I was so astounded by the idea that a change in thought might produce a change in the quality of the sound, that I developed this graphic score, which had different symbols on them. It had, in keeping with the title of the series, which was Aubergine Soup Terrine, for its ambiguous quality of meaning. I had pictures of aubergines, soup, terrines, soup in terrines, etc. And the daisy chains, which was part of the overall project that I was working with. So when one of the performers played through that piece, through that score, she mentioned that when she had played the empty terrine, having previously played in response to the picture of the full terrine earlier on in the piece, when she came to that one, she felt that the difference of the hollowness really affected her way of framing that response, and that she found that she had a hollowness of sound quality in the multiphonic that then carried on through the next and the next item on the graphic score through that journey. So that was a sort of way in which I would step back and I would think, what had we talked about, what had we found interesting, what had the performers responded to, and then created a further score in order to explore those more in more depth and be led really by that process.
That's really interesting. It sounds like a very stimulating kind of area to be operating in as a composer. Yeah. So Chris, as Zakiya said, as is probably the case with most of the composers that come to you, there's obviously this very developed musical projects that they come to you with, and they're looking to achieve certain things through the software that you can enable. So perhaps you could talk about your experience on this piece, but also others, and explain how you approach this practice, and also perhaps how you may see your own creative agency entering into the equation.
Yeah, I think that's a fascinating angle, actually, because, yeah, as I said, I am a composer myself. I mean, most of my work previously, before coming to PRiSM, was algorithmic composition, and I got into software development through using IRCAM's software development software tools back in the mid-noughties when I was finishing my PhD. So I started using those tools, Open Music being the main one, so writing music using algorithms, and it's a very different kind of thing. Machine learning is qualitatively different from, algorithmic composition, in a sense, the machine is doing trivial work for you. It's speeding up stuff that could be done by hand. Machine learning is qualitatively different. It's a different kind of thing altogether. It's not as if you could do this, but the machine is doing it faster. It's an entirely different type of thing. The machine, in a certain way, has agency. But of course, you're right. You kind of intimated that I might, in a sense, have agency myself, because as a composer, it's a creative process for me. I don't see it as it's not a kind of dry. People often imagine that machine learning is a very dry, kind of mechanistic process. But it's not. It's a very creative process. It's more of an art than a science, I would say. It's a very human process, in fact. I think that's mostly because these things are they're often referred to as neural networks, so referred to as black boxes. That's true to an extent, but I think the more kind of fascinating area is the area of parameterization, and these things have lots of parameters, and getting the right combination of parameters to get what the person I'm working with might have requested, that's the really difficult thing to do, and in a way is kind of impossible, because you can never really achieve it. You can get close to it sometimes, but you can never really achieve it. And interesting things come out of that are not intended. These things have unintended consequences, I find, that are really interesting. It's really not like the kind of cliche version of it that is out there, the machines are taking over. It's really not like that. It's a tool. It's an instrument. At the end of the process, what you get is a model. So it's essentially the neural network as a model. It's literally a file on disk. But then that is capable of producing an infinite amount of material, which is a fascinating way in which the process changes the usual kind of compositional process, which is, you have a piece, you write it, and then it's performed, and then it's done. But this is something that could, a piece could potentially go on forever. So you have this infinite resource. And I think my compositional self, in a way, I see, there's a nice phrase, actually, elegance is not optional in the context of coding. And so you want to write elegant code as much as possible. And I strive to do that. And so I think if there's any way in which my own compositional or creative self or creative voice comes through, rather than my data science self, it's in that aspect, and I think that probably influences the end result in ways which I can't really pick apart. I can't really quantify that, but I think if you took me out of the equation, if somebody else was doing this instead of me, heaven forbid, then I think you'd get a different result. But I wouldn't like to kind of quantify exactly how that would come through. So yeah, it's a creative process. I see each new person I work with, it's a new job, it's a new test of what the software can do. And of course, the software is developing all the time as well. So it's testing new features as well. So that's another interesting aspect of it is it's work in progress. It's the software is being developed through the creative process itself. So it's not simply a case of finished software, which is then being used by composers.
Yeah. And so in this case, with Sad Dog Eating, so obviously one of the concerns of the FluCoMa project is also dealing with large amounts of audio in ways that become more manageable for human beings. So in this case, just in terms of amount of sound that was generated, I mean, what are we talking about? And were there any particular strategies for kind of finding what you wanted within these?
Yeah, I mean, that's one of the things. I mean, I listen to everything that it generates. So we have a setup so that it will generate test audio as it's going along, as it's running through the data set. So a typical cycle will involve, maybe 100 epochs. So an epoch is one pass through the entire data set. So you have a data set and then you're churning through it multiple times. So the neural network is processing the data set over and over again and learning the features of it. And so this might happen many hundreds of times. But as it's doing that, it's generating audio, test audio, which I will then audition. And I mean, I'm usually the first person that hears the end result, as it were. And so I listen to everything. And so if I remember correctly, there wasn't a huge data set with this piece. In a way, we were finding out the kind of parameters of what kind of data set we could work with. So, I mean, one of the problems with machine learning is that if you have a small data set, the neural network will tend to learn it very well. And which if you're doing hard data science, you don't want. If you're predicting weather patterns, you probably don't want that. You don't want the machine to literally learn what you give it and reproduce it. So small data sets, yeah, they will tend to do that. So this wasn't a huge data set, but we have some techniques for augmenting the data, some very simple techniques. It's a fairly common strategy with image-based neural networks, but not so commonly encountered with audio work. So, for example, we might take a data set and then, so I mean, a data set, I should explain, consists of an original audio file supplied by the artist, Zach in this case, or Beethoven, the Beethoven sonatas, essentially chopped up into small chunks. So it's processing these small chunks of audio over and over again in batches. And when I say small, kind of 8 to 10 seconds, generally speaking, that's about the size. And so a data set consists of, random chunks of the original audio. If you have a small data set, one technique which we use is to overlap the chunks. So you can generate more material simply by overlapping consecutive chunks of the original audio, which seems to work pretty well. And I think we did that in this case. I tend to do it with most of the data sets I work with. It tends to require that. That's my starting point, in fact. And then if I get some decent results, I'll just leave it at that. But I might, with the Beethoven, that was large enough. That was 10 hours of audio. So I just left it. I didn't do any kind of overlapping or any data augmentation in that case. Beethoven had already done it for me, essentially. So I think the largest data set I've worked with recently was a large orchestral data set, which was around about 3/4 of a terabyte. So that was quite big. Yeah. Luckily, we have the kit we have machines that can process that kind of thing, but it still took a long time. And that's the other thing to say, to mention, is that these things often take a long time. When you're working with raw audio samples, it's a lot of data generally, particularly at higher sample rates. So that particular data set, the 3/4 of a terabyte data set. That one epoch, which is one churn through the entire data set, I think took about 30 hours. So that was quite a task. And I think we only managed to run it for about 2 weeks in the end. But the results were still quite interesting.
Yeah. It must be, I mean, for you, Zakiya, it must be quite a magical moment to kind of get back this artifact that you kind of gave in the input material, and you get this thing back. So if I understand, Chris, you listened through, but without making any particular curation or without taking things away, or you give everything over to Zakiya. Yeah. And so, Zakiya, how did you approach going through all of that data and seeing what it was that you wanted to find in it?
Yeah, I think the first thing to say is how unusual an experience it is, or it was for me at that time, to be in the position as a composer where I had genuinely no idea what it was going to sound like. And that even with the most aleatoric or indeterminate practices, usually have some idea of at least what types of sounds you might get back. So this was a really exciting. It was a really exciting moment. That anticipation and especially in today's world of instant gratification in so many areas, it was genuinely quite exciting to not have the ability to know and to just have to wait. So when I did receive the samples, what Chris had done is he had supplied sort of short generated samples from a selection of epochs, and I think that we've done some work more recently as well, and what we've sort of started to do now is to make sure that there's a generated test sample at the end of a few epochs. The latest one has been after 4 epochs. It will generate some test audio, and in this way I can audition it over time and get a sense of how it's changing over time. In the first one with Sad Dog Eating, there was a range of epochs that I was given later on in the process after it had started not just making noise or some intermediary noise sounds, and so it was very much at first just being struck by the uncanniness of the sound, just because it was at a time when I had not heard that many projects where people had fed in their own compositions. So there had been, as Chris mentioned, there'd been some projects looking at some Beethoven works and the Dada bots I was familiar with, but having lots of a range of different instruments and contemporary music as the database, that was unfamiliar to me. So the sounds that came back were I just remember sitting there and just listening and just not having any sort of reaction other than just listening so intently and so closely because it was so new. And in the end, I think what I've started to notice is that I think that there is a kind of a latent machine learning sound. There is almost like a record has its particular sound quality that is, specific to the record and the tape with that. At first, I had no knowledge of what those parts were, and so there was no ability even to disassociate the medium from the produced product. And again, that was an interesting place to be in. But in order to sort through the audio, all I was doing at that time was just trying to listen and get a sense of what was there across quite a number of epochs for which Chris had provided me 10 generated samples for each, and some at different temperatures or chaos settings, and so I was really just listening, and it was all about trying to just absorb that and then take a step back and then and then work out what comes next. What will the piece be? Because again, looking back through the process that had created the database, the data set, sorry, that was driven by the same sorts of ideas of letting something emerge and responding to that. So that was the way in which I was going through the material. But just also to say about the data set design and the length of data available, I would say that, Chris, coming from the perspective, when he's speaking from the perspective of his role as a software engineer, and he's saying that that's a small data set, I had worked with the performers over 7 or 8 workshops of 1 to 2 hours each. That's an enormous amount of material for a composer. I did, in the end, only choose 2 workshops to take the material from, because I was, at that time, unsure how this process would work, and whether or not material that was more homogeneous might be better to train the model on than a range of materials that were very different from one another. So I believe there was just under 2.5 to maybe 3 hours worth of that data set, which, as I say, for a composer is actually a really long amount of time. So I find it interesting that, it's a very different understanding of data, I think, as a composer. And it's finding the ways that this process can, how an artistic practice can develop or find a way to make use of these. So I think that I can probably talk about the ramifications of that more in the context of how I've then gone on to test different types of data set and data collection in that way. But in the context of choosing the material for this piece, it was really just looking back at the process of where I'd come from in the iterative process, and all of the concerns that we were really interested in, and the idea of this being trained completely from the input, which was the performers. There was nothing other than these workshops, and seeing what it would make of these performers having this it was a very human experience. It was a very performer driven and communicative space, and then to find what would happen then if it was what would the machine learning process, what would the black box phenomenon, the hidden layers, what does all that mean? What is it going to put out? How is it going to relate? Is it going to relate to what we did? Because essentially that is all it has to learn from. So it should. And so I was listening to hear whether that had happened or how it had happened. And it certainly was. It definitely reflected the types of sounds, but in unusual ways. And I think that's a really interesting difference between a machine learning process and what you get back from generating samples in that environment than other types of compositional practices, such as chants or Chris mentioned algorithmic composition. You get what you get back. Actually, it has more meaning. It has more of a relationship to the process and what you put into it. But at the same time, it's going to give it back to you in a way that you have no control over and could mean anything.
Mm. Yeah, it's just to jump in on what Zach said there. The process itself it's different from algorithmic composition, which often involves chance. That's true, but it's uncontrolled in the sense that it's almost giving agency to another agency, as it were. So it's not a completely chance. It's not a chance process. It's a black box. Something is going on, but we don't really understand what it's doing very often. I mean, even I, as the software developer, don't really know that. So when I run these things, I mean, one of the things that and now Zach has mentioned the size of the data set. I should say that wasn't actually that small. It was kind of a medium-sized data set, so 2 to 3 hours. Yeah, that's kind of medium size. It's a nice size, actually. And one of the things that I find is that when I generate audio, I often find I like stuff that the person I'm working with, composer, sound artist, they often will like stuff I don't like. So I have a kind of bias. I kind of wear my data science hat when I'm auditioning stuff. I like the end result to sound like what the original data set it's been given, and generalizing from that, not simply reproducing them. But as a data scientist, I like it to do that. So I know that my software is doing what it's minimally required to do, which is to generalize from a data set. But I often find that the artists I'm working with, they like the stuff that's more glitchy, more messy, stuff that really kind of maybe almost kind of overfitting a bit, which, as I said earlier, you wouldn't want if you were doing hard data science. But maybe from a creative point of view, that can be interesting in itself, because it's never really reproducing, exactly what you give it. There's always something interesting that it changes, but it's completely impossible to predict. I have tools that I use to monitor the process. It's the underlying kit I use is TensorFlow 2. So I use TensorBoard, which is a tool that allows me to monitor the process of training as it's going along. And so I can look at my charts and I can see where it's going, and I can see whether it's going to change, maybe whether the training is going to get better or worse. And then I can intervene at various points. I can stop the training and restart it. So that's how I kind of look at it. Is from a data scientist point of view. Most of the time, I'm trying to be neutral and detached. But yeah, the end results, it's hard often to match them to the raw kind of numbers that come back. You never really can predict what's going to come out of this thing, and that's what's really so interesting about it for me.
Yeah. There's one thing that I wanted to jump on, something that Zakiya mentioned that I'd like to get, Chris, your perspective on as a software engineer. She talks about the kind of latent machine learning sound. So I was talking the other day with Simon Smith, who's at Birmingham's Beast Sound Theatre, and we talked at one point between the kind of intangible kind of aspect or trace that comes with working within Super Collider or working within Max or something like that. Yeah. I was wondering, as a software engineer and with perhaps your more data sciencey background, if you had any comments on this latent machine learning sound.
It's definitely there. It's something that I mean, I listen to it all. I listen to everything that that the thing generates. I just feel I have to, it's kind of a bit of an obsession, really. There is that sound, that glitchiness. It's never exactly, it's the uncanny valley effect as well, a lot of the time with, I mean, when I was training on the Beethoven data set, I was getting, I mean, one of the things one of the parameters you can modify when you're, Zakiya mentioned it actually, is temperature. So this controls the kind of randomness of the generated output, which often gives you more surprising output if you have a kind of higher temperature, and less surprising if it's lower. So I can modify that parameter. I can't really do very much else. It's rather different from the training process, which is full of different parameters you can tweak and tune. So the generation stage itself is fairly kind of, start and stop. You start it off and it just generates the material and then you get it. I think that the sound quality, very often it will get, I mean, this is with SampleRNN. SampleRNN is working with recurrent neural networks. So RNN is recurrent neural networks. So these things are working on sequences and they're cycling through repeated patterns of data, and they will often get stuck. They will often pick out a kind of set of features that it'll just sit with for a while and just repeat that for a bit, and then randomly kind of pick up on a completely different pattern, and then generate some new completely surprising material based on that. So there is a particular sound. There's also a particular kind of structure that you get. It tends to be less structured over, I find, more than about 30 seconds. You don't really have structure. That is actually one of the research projects we're working on at the moment, is getting these things to generate more structured audio over larger ranges of time. And we have some interesting results that are going to be published quite soon. We have a paper actually that's going to be published quite soon. And so that's what our research is focused on at the moment. Building more kind of interesting structures over the long term, because we can generate audio of any length, 10 seconds, 30 seconds, 30 minutes, but it's not always predictable what it's going to be doing for those 30 minutes. I remember when I was doing the orchestral data set recently, I generated one audio file, and of course I can't predict what's going to come out. It will just do this, and then I have to listen to it. 10 minutes of applause. So there was some applause. There was some applause in the actual original audio, and so I just decided, well, I think there was a couple of seconds of some interesting kind of orchestral sounding, kind of sounds, and then it just went into applause and just stuck on that for 10 minutes. So those are interesting things. Although the person I was working with actually really liked that. So yeah. So yeah.
Yeah. One I suppose, to steer things to some more FluCoMa related stuff. So perhaps when you're talking about building up the data sets, so you're chopping up the audio in time, sometimes overlapping those windows. And do you work with, so this is like raw audio data that's being used as the audio, so it's not audio descriptors or anything like that. No. It's so we're talking about large amounts of data. Because it seems that I suppose one of the striking differences between the kind of technologies that you've been working with and the kind of stuff that's happening in FluCoMa is, I suppose, although it's not always the case, but FluCoMa is perhaps more geared towards kind of real-time stuff. So being able to use MLP regressors in real time, stuff like that. Indeed.
This is one of the things. So we've been recently working with FluCoMa. I've been doing a lot of work with it on several projects, which are not released yet, but they will be at the end of this year, we hope. One of the big things about SampleRNN is that, I said it takes a long time, and of course it's not real time in any sense. You can't really do this real time. The DataBots YouTube streaming thing is not real time, I'm given to understand. It's a slight delay on that. So it's, that's working at a much slower sample rate as well. I think it's 16K. So we are able to work at, we have sped things up recently. It's much more optimized than it used to be, so it's much faster. It's about 4 times faster than it was a year ago, so we can work at higher sample rates. But real time, no, it's not real time. This was the big surprise to me when I started to work with FluCoMa, and I didn't realize that there were neural networks as part of the toolkit. And this is what we really were interested in using, was the MLPs and the classifiers. We hadn't done much classification. We hadn't done much work with classifiers and neural networks that are involved with, most neural networks are classifying, stuff. Is it a cat or is it a dog? That kind of thing with image-based neural networks. So we hadn't done much of that, but we had a need to do that, and we had a need to do it in real time. For timbre. And so we looked around for some solutions, and in fact, my colleague Sam Salem had used FluCoMa himself a little bit. And so he introduced me to it. I think he demoed it actually for the team. And we were really impressed by it, because we could see this was a resource that we could use in the projects that we were upcoming. And also just to say that, yeah, it's an amazing resource, and thanks to the FluCoMa team for producing such an amazing piece of software, and also excellent documentation and tutorials, which were very easy to follow, which is not always the case with software projects, particularly with machine learning. So yeah, that's kind of the background for how we became interested in using it. In fact, I remember I was at Huddersfield when the project started, so go way back to, gosh, I'm not sure when it was, 2016. So I believe when it started. So I was aware of it, but I didn't really know what it was, the direction it was taking, or what it was possible to do with it. But we were very pleased when we discovered that we could actually use it.
Yes.
And so we're using the Super Collider. Obviously, there are different versions that you can use. We're using the Super Collider. We've used the Max patches a little bit, but we eventually went with the Super Collider kind of front end.
Yeah. Well, thank you, Annie, for your words especially about the documentation and tutorials as well, which is obviously something that can often be quite
very easy to follow. Yeah.
No, we've well, I say we, mostly my colleagues James Bradbury and Ted Moore have put a lot of effort into the tutorials and documentation to make sure that they're things that can be followed along. Well, and I believe you're on the forums as well, so we'll be hearing those projects.
Yes, I had a question a couple of months ago, and I just posted a question and got an answer within 10 minutes, funnily enough. So, which is very rarely the case that you get an answer at all. I try and do that with our software PRiSM. Try and answer the questions as quickly as I can, but I got a very quick answer to a kind of quite a specialist question, actually. But yeah, and it helped and it worked.
Yeah. Again, the rest of the team are putting a lot of effort into making sure that forum is a place that people can go and have questions answered. So Zakiya, I know that you haven't had much chance to dabble with the FluCoMa tools yet, but one thing that I was interested in, so obviously you're probably aware that quite a kind of standard use of the FluCoMa toolkit is for corpus exploration. So having a large amount of audio and being able to use certain technologies to be able to look through it and find things that we may want. And so I was interested to know if that's something that might interest you. For example, with the kind of stuff that was generated with the SampleRNN, how did you go through listening to it? Was it just a case of sitting down, listening to everything? Would you be interested in handing some of that heavy lifting over to a computer algorithm that you could design yourself for listening in a certain way? Is that something that you think could stimulate your creative process as a composer?
Certainly. The one thing I would say that I was thinking a lot, I would say it a lot actually during the process of creating the concatenated file for Chris to use to train the model, was I really wish someone would develop some software that could go in and just pick out the bits of audio that I want to splice together, because that was the most laborious part of that project. As I say, I had many hours worth of recorded workshops to go through to select the material that I wanted to train. So it's maybe on the front end rather than the other side. But this was what I was thinking about at that time. And I think that this would be, if it's possible on both ends, that would be a huge benefit, because I think as I said before, the data set that I was working with, it was specifically homogeneous. So I had to go through and I had to take out all of the talking in the workshop, anything around the sounds in between people playing. And this is something that I'm now experimenting in different ways with different types of data sets. So I'm thinking about how this original data set, which Sad Dog Eating was trained on, was or the parts of the piece, which I haven't really discussed how I use that in the piece, but the data set was, as I think of it, it was homogeneous in a linear sense and also in a vertical sense, because the sounds themselves were very similar. Three of the same instruments, obviously different performers, different environments, different recorded settings, which actually turned out to be a very natural way of augmenting that data. As I said before, the phones had captured the performances from different angles. So I actually had 3 different versions of each moment of that shared performance in the data set in 3 different ways. So that was already a very natural way of augmenting that data set. But then I was tasked with, as I say, sort of bringing it together. So this data set was similar in that vertically all of the sounds were more or less alike. They were all looking at multiphonics. They were all played on clarinets in this environment, and it was also horizontally homogeneous, because it was the same all the way through. There was the same weighting. I had one playing at every time, and I had simply stitched those moments together into one long file. When I came to my next piece, which will be premiered as in the unsupervised concert 2 shortly. This one I wanted to do the opposite, so I deliberately left in all of the talking. This time I was working with a tuba, French horn, and piano trio, and we had a similar. It was just after the clarinet project, and a lot of it was captured in the same sort of a way. And so there's a lot of talking in the workshops, and I specifically left it in because I wanted to know what would happen if there was talking and playing, and it was layered. And over time also they trailed off. So I put it in exactly in the time that they happened, but I layered all of the workshops together. So some of them would finish earlier and some later. And then also there was a performance that we did in one moment in the lockdown where in between the lockdowns, where we were allowed into the college, but with no audience. So we had recorded this piece that we constructed together out of this process of workshops. And that performance was also then in the data set. And that was one of the longest files. So by the time you get to the end of that file that it's learning, some of the parts that it's learning, some of the chunks will just be that performance, and some of the other chunks will be will have the many layers of talking and playing, and also somewhere in the middle. So that was the idea of that data set design. And I'm now working with Riot Ensemble, and we just recently recorded a couple of hours of a workshop looking at 3 different parts of the scores, 3 slightly different scores. And I am looking at having 3 different data sets and 3 different models based on similar but not the same material. So it's this idea of the data set design has been so important to me. And I talked a lot earlier about the conceptual ideas around each data set and why they were the way that they were and what we were exploring as the ensemble and myself. And so I think that having software that can pick out on either end, whether this is before when you're selecting data to train a model, and then also afterward, that would be an immense help. So that's certainly something that I really want to explore further. And also the live aspect is a new one for me as well, and that opens up a lot of possibilities for obviously live performances.
Yeah, no, and I suppose, we hadn't reached the subject of how, to close out the conversation around Sad Dog Eating, exactly the agency that those generated recordings had, how they appeared in the final piece. So maybe we could touch on that.
Yes. So, I did talk a lot about the process, which is why I then had to stop myself from taking up all this time earlier. So so to finish the discussion of how that piece was created, after I had taken stock of what the generated material had come back as, I then what I wanted to do was I was looking back all of the stages of that process, going right back to the beginning and our workshops together. And what I wanted was to show every iteration of this data, of this music, of this work. I wanted to show every level of it, of this cycle. So I, first of all, within a structure also that broadly went from the idea of human-only created sound to the middle section, which encompasses all of the different levels and types of technological mediation, including the raw data that was only mediated by the instrumental practice and the Zoom, and also layers of machine learning material, and then back to a human-only sound, which is the Laurel, one of the performers, she was whistling. And where some of these two ends come from, when you go from the beginning and then out to the end, you hear the clarinetists playing some new material as well. And that material was derived from a further process of composition that I had done after I'd collected the samples. And I layered them together. I layered them together in ways that I liked. I chose samples that I found interesting for various reasons, and I layered them together in my platform, and I created loops out of them. And I then met with the clarinetists one further time after the process, after the machine learning generation process, and they listened to these layered samples, and they acoustically reinterpreted them. And what was really, really interesting about this particular part of the process was that because I had layered the generated samples, and because the generated samples have a further level of unknown locality, unknown attack. One of the interesting things about machine learning generated music is that it can produce things that are simply not possible. It's not possible generally to have the second half of a clarinet tone without hearing the attack, unless you have used creative orchestration to disguise that. But to just have that, or to have what sounds like almost like a backwards sound, that's not usually possible in that sort of a way. So what happened was that because all of these things were all laid together, and each individual one was already very obscured as to what the origins of any of these sounds were, when the clarinetists were talking to each other and talking to me about what they were hearing in these loops, they had very different ideas about what parts of the material was related to other parts. What was the start of a thing and what was the end of a thing, or what things were attached together. Some of them perceived things to be two different sound events that were not related, and the other performer felt that they were connected and connected to this other one. So this is where the title of the piece comes from, is that one of the responses that one of the other clarinetists had, Grace, she mentioned that she was talking to Laurel, and she said, oh, the bit that sounds like a sad dog eating. And that was the moment at which I knew that was going to be the title of the piece, because immediately I thought, that sounds like what you would expect a machine learning text generation to spit out back at you. You're not expecting, seeing that on a page. I would imagine that had come from a process that was involved machines, and certainly it did in its historical origins, but that was something that a human had said. That was a human interpretation. So that immediately really contextualized as well what I was going to do with all of the material that I had then collated by that point. So I had the original raw generated data set, which I layered in the middle of the piece. I had the raw generated samples, so samples produced to me by Chris, that had not been interfered with in any way. That they were used in, one of them is used in the opening right after the performers finish, and there is a moment of almost, to me, it was almost like a virtuosic entry, a bit like in a concerto. It's that moment of quiet, and then something has arrived, and this is the focal point, and you must listen to me and my virtuosity. That was the first sample that you hear. It was used in that way, and that is not interfered with in any way. But then later on, in this middle section where all of these layers are happening together, that's when I also had the clarinet performers' responses to the loops, but then also I had started to use some sound design techniques to again sort of mystify the origins of the transmutation of the sound. So in all of this, the purpose of this piece is really just to look at this many layered onion that is the human and machine and human and machine and human and machine process. So that is the overview of the piece.
I have to say, I didn't actually realize that that's where the title came from. So it's nice to hear that. It actually, Sad Dog Eating does sound a little bit like something you might get out of a text generation AI. So it's kind of, to hear that it's from a human being, it's kind of ironic in a way, I think.
Yeah, that's why that immediately I knew that it would have that impact, and that's why I thought it was so effective.
Great title.
But it's certainly a really intriguing piece, and it will, of course, be linked down below this video. So go and give that a listen before or after, if you haven't yet. Chris, one question, perhaps quite practical, but I think many of the people listening may be asking themselves is, for example, would I be able to run this kind of software on my old 2012 MacBook?
Probably not. It would be an interesting challenge, actually. If any of your listeners want to write in and tell me their experience with that, no. We have specialist kit for this kind of thing. You need GPUs, graphic processing units, and which are not cheap, but we were able to get hold of some very good quality ones. The latest generation NVIDIA GPUs is what you need. I mean, these kinds of things. Well, I mean, it's different. It's a bit of a contrast to FluCoMa. I mean, FluCoMa, you can run FluCoMa neural networks, on your local machine very easily because they're very fast, real time. This kind of thing is different. It requires a lot more juice and it takes a lot longer. We do have a Collab notebook, which is on our GitHub page, on the GitHub README. There's a link to it. So you can play around with the software there. For those who don't know, Collab is Google's GPU-based online environment, so you can get access to a GPU for free in the cloud. Not the latest generation GPU, so it's never the kind of experience you would have with the latest generation NVIDIA GPUs, but it's usable. We have done some work with the latest MacBook, the latest Mac chip, the M1 chip, actually, and I think that the M2 has just recently been released, hasn't it? We were surprised to find that SampleRNN works pretty well on the M1 chip. It's pretty fast. Not as fast as the typical GPU, NVIDIA GPU, which is highly optimized for this kind of thing, but it's doable. You can do it. In fact, we were discussing, Zach and I yesterday, we were discussing this very question of how more people can use it, themselves on their own hardware. And that certainly, I mean, in the future, I can see this thing being these kinds of software, these kinds of heavyweight neural network packages being used more widely. So maybe that answers your question.
Yeah, I would like to jump in and say that I have run PRiSM SampleRNN on an old computer, but obviously through the Google Colab. So it can be done. You do need to have a lot more time available to you. That's the only thing to have the session time, and not leave the Wi-Fi if you're working on a laptop. But if you've got a desktop computer and you can set it to run for a few hours, I mean, it's definitely possible. And it's actually I would say it's quite accessible in that way. I've done some work recently, actually working with some young artists who have recently used the software in this way. And so it is quite accessible as an entry point, as a first sort of have a a go as a sort of a make in the spirit of a maker sort of sound artist is possible.
Yeah.
Yeah, it's good to know for people who want to try it out.
Yeah, as I say, the link is the link to the collab notebook, so you can play around with it. It's usable. Yeah, I mean, you can do stuff with it.
Yeah, great.
Although perhaps not trained on the entire Beethoven symphony of piano sonatas, maybe that might not be possible. But who knows?
Cool. So perhaps just to finish up, I had a few perhaps more broader questions that I was wanting to ask you. There's one aspect that I think intersects both of your practices, and it's the idea of data in quite a large sense, how it can be used, manipulated, or perceived of in order to make music. Obviously, an aspect that we've discussed with the FluCoMa project is to manipulate corpora, and there are times when audio is considered as a data set. However, data sets can be comprised of many things. Perhaps to begin, Zakiya, I'd be curious to hear about your ideas on this. So for example, how do you approach data as an aesthetic object when you're working with scientists?
It's a good question that is it's challenging, I think, to answer in maybe one capacity only, just because I have maybe that's not a problem, but I've worked with data in lots of different forms through my work with scientists in the areas that I discussed earlier. I worked with Connected Health Cities a few years ago, and I wrote a piece that reflected their project, which was the health data scientist driven program that was set up in order to help health data scientists communicate their research more directly with each other. And so data in that context was very different from data in the context of when I was working with Dr. Kirsty Andrews, who's a biochemical engineer. And then data again when it comes to the idea of the data sets that I've been talking about. So I think it has, I think really for my practice, it really just means anything that I am collecting in large enough numbers for it to be considered in a corpus, I suppose, and has some interrelation with itself or with the project, and is something that I'm using to inform a compositional process, or directly in some kind of transmediation or not quite translation. I don't sonify, so that's one thing that I think is sometimes more closely related to the idea of data and music. But actually, what I find interesting is these sort of more curious ways of coming about the use and inspiration from data. So I'm not sure if that answers your question. Yeah.
Perhaps I just to kind of jump in there on the question. I mean, I work a lot with data sets. I mean, a lot of the kind of heavy lifting at the beginning of the process is in, generating the data sets. I mean, that takes up an awful lot of my time. But I mean, one of the big differences between SampleRNN and FluCoMa, for example, is that with FluCoMa, if you're doing an MLP classifier, then you're working with the data sets that we use, they're completely unsupervised. So you're not labeling any of the input data at all. It's simply the raw audio. So what you put in to the network, it just gets that, and it learns the patterns itself. So it has no help, as it were. So it's a kind of raw process. I've worked with different sizes of data sets. As I said, I think the largest I've worked with was 3/4 of a terabyte, which was huge. But I mean, to come back to that Beethoven guy again, I know he's, if you're working with a composer, a living composer, because the composers I work with, data scenario, they're living composers. So we work with contemporary music, current forms, current music. Beethoven, obviously, he's got a large corpus of music. That's one of the advantages of dead composers, that they have a lot of material, a lot of homogeneous material as well. Beethoven sonatas, you're unlikely to get that with a current living composer. composers these days tend not to write piano sonatas, although sometimes they do. But even if they do, it's hard to expect a living composer to have amassed a huge amount of homogeneous data in the sense that we have with Beethoven. So it's a challenge. It's very difficult to kind of square that circle in a way. One of the approaches is, as I mentioned earlier, is data augmentation, which we can do a bit. But the data set is probably the thing. Preparing the data set is probably the thing that gives me the biggest headaches, if you like, if there's any headaches involved in this process.
Yeah. And do you sometimes feel, from your perspective of an engineer, which obviously in data science you have possibly quite a specific idea about what data is and how it's organized in a data set. Do you sometimes find that can come at odds with how someone who might not be so technically fluent may conceive of collections of data? Do you find yourself having to navigate different ways that people conceive of these collections of things?
Well, because I work with so many different people, so many different artists, the different types of audio that I get, the different types of data set that I get, it's quite extraordinary. What I do find that homogeneity is something that helps, but homogeneity, what does that mean? Beethoven again, you've got an awful lot of music, piano music that sounds very similar. But then if you're working with somebody who's provided me with field recordings, all of those field recordings will have different sounds in them, but in a sense, that's also a form of homogeneity, because the very fact that there's no homogeneity in the data set is a form of homogeneity in itself. So it actually works quite well, actually. It tends to learn field recording stuff really well. But with that kind of data set, you have to be careful, because what you get out is, if you give it that kind of material, you're going to get that kind of material generalized back from the neural network. So I like working with that kind of material because it's easy to work with, and I get really good results really quickly. Music, quote unquote, whatever that is, that's the real challenge. Orchestral music has been difficult. So early on, we started with some orchestral data sets. And we discovered the hard way that that was a hard thing for it to learn. But recently and I think high sample rates as well. Recently, we've been working at much higher sample rates, 44.1 kilohertz, and that has really helped. So you're processing much more data in one kind of step of the neural network, and it likes data. It likes lots of data, so it can generalize, so it can learn all the different patterns, but not simply learn the patterns, but generalize from them. So if you have lots of data, that's not a bad thing, but it also has its own kind of challenges.
Yeah.
If that answers your question, Jacob.
Yes. Great. No, that was really good. It's been really interesting to hear about the differences, the different time scales, the different scales of data, stuff like that, because it's obviously similar in lots of aspects, but very different as well as a practice, and in terms of what it can offer people creatively. And it's been really interesting to hear about that. So thank you both. I think that's been a really interesting chat. So as I've said, I will be linking to all of the things that we've discussed today down below on the page on the FluCoMa Learn website, where this video should be living, and obviously there'll be a link to that in the YouTube description as well. So Zakiya and Chris, thank you so much. It was a pleasure.
It's Jacob.
And I shall speak to you again soon.
Thank you.